Hey there, tech enthusiasts! Welcome back to our channel. Today, we're diving into a fascinating topic in the world of artificial intelligence, the difference between training and inference. Whether you're a seasoned AI professional or just starting your journey, understanding these two concepts is essential. So, let's get right into it. But before we jump in, here's a thought-provoking question. Have you ever wondered how AI systems learn and make predictions? Well, that brings us to the core of our discussion today. Let's begin with training. Think of training as the foundational phase where an AI model learns from data. Imagine you're teaching a child how to recognize different animals. You wouldn't just show them a cat once and expect them to remember it forever, right? You'd show them multiple pictures of cats, along with other animals, explaining the differences. In the AI world, training serves a similar purpose. During this phase, we take a large data set, which contains both input data and the corresponding output, and feed it into the model. The AI learns to identify patterns and relationships within this data. For instance, if we're training an AI to recognize handwritten digits, we would use a dataset like NIST. This dataset contains thousands of images of handwritten numbers paired with their labels. The model processes these images, adjusting its internal parameters to minimize the errors in its predictions. This process is often computationally intensive and can take a significant amount of time, especially for complex models like deep neural networks. A practical example of this is Google's TensorFlow, a popular framework for building machine learning models. When you use TensorFlow to train a model, you might input thousands of images of cats and dogs, labeled accordingly. The model will learn to distinguish features like fur patterns, shapes, and sizes over many iterations. Now, this leads us to a critical term, overfitting. Overfitting occurs when a model learns the training data too well, including its noise and outliers. Imagine teaching a child to recognize a cat by only showing them pictures of your pet. They might not recognize any other cats because they've only seen one specific example. To combat overfitting, we often use techniques like cross-validation and regularization, which help the model generalize better to unseen data. Now, let's shift gears to inference. Inference is where the rubber meets the road. Once we have a trained model, it's time to put it to work. Inference refers to the process of using the trained model to make predictions or classifications based on new, unseen data. For example, let's say our trained model on handwritten digits has now learned from the NIST dataset. When we present it with a new image of a handwritten digit, the model uses its learned knowledge to infer what that digit is. This phase is typically much faster than training because the model is simply applying what it has already learned, without needing to adjust its parameters. According to recent studies, the inference process can be incredibly efficient. For instance, a well-optimized model can infer results in milliseconds. This makes it possible for applications like real-time speech recognition or image classification on your smartphone. But inference isn't just about speed, it's also about accuracy. The quality of predictions during inference is directly linked to how well the model was trained. If the training phase was thorough and the model generalizes well, we can expect high accuracy during inference. Now, let's talk about some practical applications. Consider self-driving cars. During the training phase, the AI system processes countless hours of driving data, learning to recognize pedestrians, stop signs, and obstacles. During inference, the trained model analyzes real-time data from sensors and cameras to make instantaneous decisions on the road. Similarly, in healthcare, AI models are trained on vast datasets of medical images to recognize diseases. When doctors use these models to analyze new images, the inference process helps them diagnose conditions quickly and accurately. To wrap it up, understanding the difference between training and inference in AI is crucial. Training is all about teaching the model using large datasets, while inference is about applying that knowledge to make predictions on new data. Both phases are vital for creating effective AI applications that can transform industries and improve our daily lives. So, the next time you interact with AI, whether it's through a virtual assistant, a self-driving car, or a recommendation system, remember the hard work that goes into training those models and the magic that happens during inference. If you enjoyed this video and found it helpful, please give it a thumbs up, subscribe to our channel, and hit that notification bell so you never miss an update. Also, feel free to share your thoughts or questions in the comments below. We love hearing from you. Until next time, keep exploring the fascinating world of technology. Bye for now.